For anyone who might not be familiar with FirePro, I'll just begin by saying that the FirePro brand is a brand associated with AMD's professional graphics and GPU products for the data center. That is to say, HPC and virtualization. And as distinct from our consumer-oriented graphics and GPU products, the FirePro products are all exclusively designed and manufactured by AMD to professional standards for the most demanding environments. And they're shipping in workstations and servers from major OEMs, including Dell, HP, Lenovo, and Apple. Looking at stream technology in a little bit more detail, this is about the capabilities, both hardware and software, which enable GPUs to be used effectively in the data center for compute tasks. And a big element of that is the ability to scale to multi-GPU installations and to support peer-to-peer communication between GPUs on the PCI Express bus to enable more effective use and more effective scaling of multiple GPUs. All of our GPU products, which are targeting compute, support ECC memory for better data protection, and universally they all support fast single precision and double precision floating point performance. Looking at the GPUs in the data center and specifically for compute, and there's some important aspects both generally of the characteristics of GPUs for this workload and of our product line that I'd like to start with. I guess the first is double precision floating point performance, because the GPU really provides a great vehicle for attacking problems that require very high levels of single precision as well, but particularly double precision floating point performance. Within the classes of GPUs or coprocessors that can be used for HPC kind of problems, the FirePro series at each price point, and including in absolute terms at the top of the stack, have leadership in terms of the memory size, allowing the maximum amount of memory to be used to attack a given problem. Perhaps most importantly on this slide, GPUs deliver not only great performance, but really excellent performance per watt as compared to traditional approaches using processors such as x86. OpenCL is the programming API which provides the primary vehicle today for harnessing the power of the GPU for these sorts of compute workloads. And our entire product stack in the S-series targeted at compute supports PCI Express 3.0 for fast communication between the GPU and the host. Just a few days ago, the Department of Energy here in the US laid out a list of the top 10 biggest challenges to getting to exascale computing. And on that top 10 list, one of the big challenges was energy efficiency, because even if the scaling of the solution were possible to build an enormous number of nodes to build an exaflop system with today's technology, the power consumption demands would be prohibitive. So effectively, you need about 10 times the power efficiency that today's solutions can deliver in order to build in a reasonable, practical way an exaflop system. So it's really important, both today for total cost of ownership and as we look to the future, to have the maximum amount of performance per watt. With all that as backdrop, I'll talk a little bit about where we're focused in terms of workloads for HPC with our FirePro GPUs. Because the GPU is, as powerful as it is not a one-size-fits-all solution. There are certain classes of workload where it really does stand out. The fast double precision performance to attack scientific problems, high bandwidth access to memory with our graphics DDR5 memory interface, a large memory footprint for dealing with complex problems, and programmability through OpenCL 1.2 or now OpenCL 2.0. The oil and gas market is also one that is very amenable to acceleration with GPUs, leveraging high performance single precision for seismic processing or double precision for reservoir simulation. And this is a market which in some cases may want to leverage OpenCL, or in other cases there will be substantial legacy code bases that were generated using OpenMP. And as I'll mention in a couple of minutes, we are introducing OpenMP support for our FirePro products to service this market as well. And finally, what is, at least in terms of GPU compute, an emerging but important market is deep neural networks or machine learning. And this is a market that we see as becoming very important in the future for GPU acceleration. It requires, generally speaking, very high single precision performance, a large memory footprint, and support for the latest OpenCL standards. Looking at our FirePro S-series product portfolio, and I'll just digress for a second and say that In the FirePro product line, we have the W-series products, where W essentially indicates products that are intended for use in workstations on the desktop, and the S-series, which are products intended for uses in servers or the data center. And as I mentioned earlier, these data center-oriented products can be used for either compute or for virtualization, depending on the particular product. But for compute, the heart of the roadmap are the dual slot products, the S9000 through the S9150. So these are products at a range of price points with a range of capabilities, all with a mechanical design that is able to fit into the vast majority of server platforms available in the market today, and a thermal design, which again is well accommodated by most servers in the market, with even the most premium of those products fitting into a 235 watt TDP. It is the first GPU to achieve both 2 teraflops of peak and of sustained low precision floating point performance, which, to give you some context, is almost twice the performance that would be achieved by the most comparable product from our major competitor. It also has industry-leading performance per watt because it achieves this performance at a very modest 235 watt TDP. And again, compared to the most comparable flagship single GPU product from our competitor, we have 33% more graphics memory available, and support posted on the website today for OpenCL 2.0, which is the latest iteration of the OpenCL standard. Looking at a few of the important speeds and feeds associated with the S9150 product, in terms of peak double precision performance, it's over 2.5 teraflops, over 5 teraflops of peak single precision performance, which works out to in excess of 10 gigaflops per watt of peak floating point performance. The basic building block of the GPU in terms of the processing is what we call a stream processor, and the GCN, or Graphics Core Next Core, is composed of a number of these stream processors working in parallel. In the case of the S9150, we have 2,816 stream processors, which can be applied to a problem. And this is really the key ingredient that makes it so well suited to addressing very parallel problems. As I mentioned earlier, 16 gigabytes of fast GDDR5 memory on a 512-bit wide memory bus, and a 235 watt TDP. Now, that S9150 product, which I just talked about, we announced last week, to our great pleasure, has been installed in a new supercompute cluster in Darmstadt, Germany, by GSI. They're a so-called LCSC cluster, and this cluster, when fully built out, will consist of 640 FirePro S9150 cards with a floating point capability in excess of 3 petaflops. Now, of course, hardware is only half the equation. Having great hardware is certainly a necessity, but there's also the necessity for it to be surrounded by an ecosystem, and particularly a software ecosystem, to allow our partners and developers to harness the power of this hardware. And one of the key ingredients to do that is OpenCL. And OpenCL is very much beginning to displace proprietary APIs as the preferred approach to harnessing the power of not just GPUs, but co-processors of all sorts, whether those be x86-based co-processors such as the Xeon Phi, FPGAs, or other devices. So there's a huge number of ISVs that have either in the past worked with proprietary APIs for co-processor acceleration, or have worked strictly with x86 and are looking to make the jump into accelerated hardware that are, in both cases, looking at OpenCL as the preferred vehicle to do that. So as I mentioned earlier, the current state of the art in terms of OpenCL is OpenCL 2.0, and it has a couple of very substantial improvements over the previous 1.2 iteration of the OpenCL standard. Key is the shared virtual memory and the generic address space, which dramatically simplify the programmer's job as compared to what was required previously, because both GPU and x86 code can preference a common virtual address space. OpenCL 2.0 also introduces nested parallelism. Now, we do recognize that not everybody wants to do all the OpenCL work themselves. In some cases, our partners would prefer to have some assistance, either from us or from a third party, or in some cases even completely offload the work of taking legacy code and moving it to OpenCL. And we have support for that. There's more details at AMD's OpenCL zone at the URL shown on the slide. And there's also a link here to CodeXL, which is AMD's in-house debugging, profiling, and analysis tool, which includes OpenCL support. I'll talk now just about a couple of examples of how our partners have made use of OpenCL to harness the power of the GPU. And the first example I'd like to discuss is ProMax, which is an open source molecular dynamics package. This was a package which has existed until recently only in a CUDA form. And our partners at Stream Computing ported this in actually in fairly short order from CUDA to OpenCL. So it being an open source package is now available with OpenCL support. So this is interesting both for its specific value as a molecular dynamics simulation, but also as an illustration that it's not that difficult to take code which may have been written for another API. Another example that I'd like to call out is Scilab, which is a mathematical simulation package that has OpenCL support. And the great value of a package like Scilab is it takes the difficulty or the complexities of working with OpenCL and abstracts them away for people who want the power of this acceleration, but maybe generalists and not specifically programmers. So this is a package that makes it very simple to do mathematical work and harness the power of OpenCL without having to spend the time to learn all the complexities of programming or working. Now, OpenCL is a very powerful API, but it is not necessarily the perfect API for all applications. And in recognition of that, we're introducing support for OpenMP and in fact OpenACC as well to our GPUs, beginning with OpenMP4. So through a partnership with PathScale, we will be introducing beta support before the end of this year for OpenMP 4.0 and a production release early in 2015. One question that comes up quite a lot is how to compare AMD's FirePro hardware with other hardware that they might be looking at from other vendors. And a particular challenge in this is that we're working primarily with OpenCL, and other vendors, NVIDIA in particular, have their own proprietary API. And it's difficult to ensure that you're making an apples-to-apples comparison. And one useful tool which is available for making such a comparison is SHOC, the Scalable Heterogeneous Computing Benchmark, which is developed in conjunction with the Oak Ridge National Laboratory. And the results you see on the slide here are the Tesla K40, an NVIDIA product, running the CUDA version of this, and the FirePro S-9150 running an OpenCL version. So it is a fair apples-to-apples comparison in that it's the most optimal interface for each GPU. And in that apples-to-apples comparison, you can see that our flagship product, the S-9150, is substantially advantaged on a number of tests over the Tesla K40. Finally, I'd like to point out that a very important focus area for us over the last half a year or so has been to establish a broader set of system and hardware partnerships so that a customer seeking an overall solution can easily take a FirePro card, put it into a wide variety of server data center systems, and have confidence that it is qualified and will run correctly and without problems. So this is a list which you can expect to see expanding over the near future. But I will call out a couple of the partners specifically because we have their systems on display here. And around the other side of the booth, there's a sled system from Gigabyte, which is basically 4 sleds into a 2U form factor. There's a 3U high 8 GPU ASUS system on the other side of the booth behind me. And we also have a Super Micro system on that side of the booth.